Welcome back. In this session, I'm teaching Chapter 3 Agentic AI Foundation. Our objective is to understand and demonstrate a deterministic agent rule. Deterministic means the same input gives the same output every time based on explicit rules. At this stage, we are not depending on LLM's creativity. We are building a reliable base layer for intent detection, lead scoring, and escalation decisions. In this chapter, we will mainly work with 4 files: readme.md, app.py, agentic_AI/agent.py, and tools.py. Readme.md explains the chapter purpose, project structure, and product stakes. App.py is a starting point of the application. It handles terminal input, terminal output, and loop control. Agent.py is the orchestration layer. It coordinates the agent workflow and builds the final JSON response. Tools.py contains the deterministic tools. Here, tools means simple Python functions used by the agent to perform specific tasks, such as detecting intent, scoring a lead, and deciding escalation. So the simple flow is app.py receives the customer message, agent.py coordinates the workflow, and tools.py applies the business rules. Now I will run Chapter 3. First, I will go to the project root folder. I will type cd and the project root. Now I will activate the virtual environment with help of PowerShell command. Now I will move into Chapter 3 folder. Now I will go to the Chapter 3, cd Chapter 3. Now I will type python app.py. The application is now asking me to enter customer message. I will take the first message. For this first message, the system should detect the pricing inquiry. It sees the word pricing, and because pricing is checked early in the rules, the intent becomes pricing inquiry. The lead score starts at 3, then it adds points for commercial intent. Because pricing is present, it also adds points for enterprise, CRM, and integration signals, so the expected lead score is 8. There are no escalation keywords like paid, refund, angry, cancel, or frustrating, so escalation should be false. Now, I will take the second message. For the second message, the system should detect a support issue. The words paid, not activated, and frustrating indicate that the customer has a problem after payment. The lead score may stay close to the base score, but this message does not strongly show buying intent or enterprise readiness. Escalation should become true because paid and frustrating are sensitive support signals. This is exactly the kind of message that may need human attention. Now, I will take third message. For this third message, there are no pricing words, no support issue words, and no product feature words, so the intent becomes general question. The lead score stays at the base score of 3. Escalation remains false. Finally, I will stop the app. I will type exit. Now, let us understand what happens behind the scenes. The runtime starts from app.py. The main function prints the chapter and starts a loop. This loop keeps asking the user to enter a customer message. For every message entered by the user, app.py calls build agent response and passes the message into it. Build agent respond-agent response returns structured JSON and app.py prints the structured JSON to the terminal. If the user types exit or quit, the loop stops. So app.py is only the interaction layer. It does not contain the business rules. It only handles input, output, and the loop control. Now let us understand agent.py. Inside agent.py, the key function is build_agent_response. This function coordinates the deterministic pipeline. First, it calls detect_intent with the customer message. Second, it calls score_lead with the customer message. Third, it calls decide_escalation with the customer message. After these three tools return their results, build_agent_response creates a payload dictionary. That payload contains fixed fields: intent, lead_score, customer_reply, internal_summary, should_escalate, escalation_reason, and next_action. The payload is converted into formatted JSON using JSON.dumps indentation. So agent.py does not directly contain all the business rules. It collects raw outcomes from tools.py and packages them into a consistent response format. This is why agent.py is the orchestration layer. Now let us understand tools.py. This file contains the deterministic business logic. The first tool is detect_intent. This function converts the customer message to lowercase, so matching is case insensitive. Then it checks keyword groups in order. First, it checks pricing, such as price, pricing, and cost. If one of these words appears, the intent becomes pricing inquiry. If the pricing is not matched, it checks support issue words like paid, refund, not activated, frustrating. If one of these appears, the intent becomes support issue. If support is also not matched, it checks product fit words such as demo, integrate, integration, and workflow. If one of these appears, the intent becomes product fit inquiry. If nothing matches, the default intent is general question. The important teaching point is that this function uses ordered checks. The first matching condition wins, so order matters in deterministic logic. Second tool is score_lead. This function also converts the message to lowercase. It starts with base score of 3. Then it adds 3 points for high commercial intent words such as pricing, demo, buy, or business. Then it adds 2 points for enterprise or integration indicators such as enterprise, CRM, or integration. COFs. Finally, it caps the score at 10 using min score 10. So the scoring logic is additive and rule-based. This creates a quick, deterministic qualification score for sales workflows. The third tool is decide_escalation. The function checks whether the message contains sensitive or risk-related language. It looks for keywords such as paid, refund, legal, frustrating, angry, and cancel. If any of these keywords appear, it returns true. Otherwise, it returns false. This is important because some customer messages should be handled carefully. Payment issues, refund requests, legal concerns, cancellation requests, and angry messages may need human intervention. So decide_escalation gives the agent a simple safety control point. Now let us understand why this chapter matters. In production-grade agent systems, we need predictable control points. Intent routing helps the system understand what type of customer request came in. Lead scoring helps the system identify valuable or high-priority leads. Escalation policy helps the system flag sensitive messages for human attention. When these parts are deterministic, teams can test and trust the behavior. The same message should produce the same classification, same score, and the same escalation decision. This chapter also teaches clean separation of responsibility. App.py for interaction. Agent.py handles orchestration. Tools.py handles business rules. This separation improves readability, maintainability, and testability. If intent detection is wrong, we inspect tools.py. If response packaging is wrong, we inspect agent.py. If the terminal loop is wrong, we inspect app.py. Students should verify 4 things by running this chapter. Intent should change based on keywords. Lead score should increase for buying and enterprise signals. Escalation should become true for sensitive support language. The JSON output shape should remain consistent for every message. Common mistakes are expecting open-ended LLM-style responses, changing keyword rules without retesting sample messages, ignoring condition order in detect_intent, and forgetting that deterministic systems depend on careful vocabulary design. To summarize, Chapter 3 establishes a deterministic agent loop with explicit rules. The system classifies intents, scores lead quality, checks escalation risks, and produces structured JSON. The tools in tools.py perform the core decision tasks. Agent in agent.py coordinates those tools. The app in app.py runs the terminal experience. This gives predictable behavior and creates the foundation for the next chapter, where we add RAGs for fact-grounded responses while preserving the same orchestration pattern.